Broadcast is now starting. All attendees are in listen-only mode.
All right, so we'll first copy today's jar file. Yesterday we had some error due to some space. Okay, so I've cleaned up the space and now it is working. I've tested it already, but I'll show you that how to copy any file from standalone machine to server whenever any successful jar file is compiled and created. So in order to do that, you'll have to open a Cloudera, and this is my Cloudera running in VM. Let me open a terminal. What is important first? So get a present working directory and then get IP address. And to know the IP address in CentOS, Ubuntu, Fedora, Debian, Mac, we have a command ifconfig. So always you need a server IP where you're copying your jar file. Okay, so destination IP is required. You have two things: standalone and server. Standalone is your source machine, and server is your destination. This is the IP address which I will use to copy my jar file. Okay, so you guys have WinSCP, and similar way my machine is having CyberDuck. That is the software for me. This is the jar file we had moved yesterday. HD 8am weekday .jar. Okay, I have shared this video already to you guys. You can watch it and see how this jar can be created. After creation of this jar, then I'll open CyberDuck. Okay, open connection. I'll choose protocol SFTP, simple file transfer protocol. And guys, this is not just for Cloudera. Okay, make sure that whichever cloud you're using, suppose you're using GCP, right? So let me create one quick flow for GCP also. So if I'm doing from any standalone machine, okay, this is my local system, and from this local I'm copying to, let's say this time, Cloudera. So my server is Cloudera. This is one. My server can be GCP also. My server can be on Amazon Web Service also. My cluster can run anywhere, right? So all this machine you're doing the same thing. If you know one concept, how to move your file using this FTP software, you can copy anywhere. I'll give you one. Okay, then GCP or AWS you can test with your Putty-Zen. You have a Putty-Zen and WinSCP. So this is the server IP, and here you'll have to give a destination server IP. What is the destination server IP? IP address of this machine where you want to copy. So 192.168.20.133, 192.168.20.133. Okay. Username is, you can check it from here, typing who am I. So who am I command will tell you what is the username, which is Cloudera in my case. I'll give Cloudera. Password it is taking by default because I have used it, but password you must be knowing, right? So in my case, this password is also Cloudera. Once you have given this, okay, once you have given this information, then we'll connect it. Click on this. When you say connect, it will ask to accept one RSA key from the server sent by your server. I'll say allow. Once I say allow, then this is connected now. So this screen which which you're seeing, this big screen, is from Cloudera. This is coming from Cloudera. Can you check it here? /home/Cloudera. Now, if I copy anything, it will by default copy in this machine, which is running over CentOS. Okay. So I will copy this to desktop. Let's say I want to copy this to desktop, and I want to copy my jar file. So I can take this and move this just using a simple drag and drop option. Nothing fancy. Once you connect it and then drag and drop. After copy, we will re-verify also. This is giving one acknowledgement that the copy has been successfully completed. You can see this. Once this is over, you can minimize this and check the file is listed in your desktop. Now, I want to verify. So here I'll go and check my, I think I have copied to desktop. Yeah, this is the jar file. hd 8am weekdays.jar. This was the jar. It has copied just recently. And this is the desktop where I can see my logo. Now, this logo I was talking about, this is the file which you submit from your client machine. And what was the command to submit a jar file? If you're able to recall how to submit the jar file from client. So this is my client. I'm running below command from client. Hadoop jar name. So in place of jar name, you'll have to give this. You'll have to give this name, hd underscore 8am underscore weekdays dot jar. Then your class name, then your input file, then your output directory. Input and output. This is the thing which you submit from client. Input, we know this is your actual file, whatever size of data you have, 500 MB, 200 MB, 1 GB, 10 GB, and output will be created at runtime. So 3 already spoke about that. You get unsupported version error if you're having any version dependency issues. Then second, you get input path does not exist if input file is not available in the path. Output file already exists if this is already created in your system. This 3 major error comes. Then we have submitted our file using this process. Client is already having a data. Next to this, I have HDFS. Okay, so that's my HDFS. Now this client has already copied the data, and this is my data. Currently, according to our multi-node cluster, we have how many slave machine created here? So we have total 4 slave machine, right? This is my 1, then second, third, and fourth. And how many services are running in this slave machine? We have data node, and we have DN1, NM1, node manager 1, DN2, NM2, DN3, NM3, DN4, NM4, right? Node Manager 4. And this data is already distributed in this machine. So I'll continue with the yesterday file size only. We had 500 MB of data. So this data size was 500 MB, and specifically this data was related to election data, right? So can I write somewhere that this information is related to election data? Because we are doing election analysis. So election underscore data. The size is 500 MB. So 500 MB means total will get 4 block, and this is in rack 1, this is in rack 2, this is in rack 1, this is in rack 2. And how this is copied? So A, then replica of this A will go to R2, then B, 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 C, 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 then D, D, D. 3 plus 3 and 6, 12. Total 4 into 3, 6 block. 384, 128, 3 blocks, and 116, 1 block. Simple calculation, 500 divided by 128. Now these are having one CPU running, one V CPU. This also has a one V CPU, one V CPU, and one V CPU. So we know that they can process 4 tasks in parallel, because virtual core processing unit is 111. So 4 process can be submitted parallelly. This is what is a parallel computing. And whenever client submits this jar file, whenever client submit this jar file, where it goes, where it communicate first. So this communication is going as follows. This is going to resource manager. You can see, okay, you can see this when we submit the jar, it will always go to 8088, and 8088 is a port number of resource manager, if you're able to recall port numbers of all the services. Then resource manager knows all the location of node manager, but it doesn't know where is data node located. And to get the detail of data node, it will first seek information from name node. Then it will provide this information based on their data locality concept. Okay. Then resource manager start submitting the job submission. After some time, when they submit it, they give one acknowledgement. This communication is continuously going from master to slave and slave to master, but all the order or assignment is provided by resource manager. This is the guy who is assigning, and they are the node who are working internally. Case number 1 is already done. I'll go and see the case number 2 and 3. There are multiple cases. So in my case 2, what if I lose this machine? So I was processing A block here in this, since one CPU is available, then B right here, then C here, and D here. I know 4 tasks are running parallelly. Now question is, what after some time, when this job is submitted, job will have some name based on the timestamp. So job underscore 574209172. Some name it will have based on the timestamp. Okay, I'm just giving one random number. Once they start running, then you'll see mapper percentage and reducer percentage. I'll come to this mapper and reducer. What exactly is this? This will start from 0% to 0%. This will start from 0% and 0%. So map produces two individual phase, okay? Two separate phase. It's not just one phase. How many tasks total running? So how do we decide the task? Number of block is equal to number of task is equal to number of, there is one more term which I'll introduce when we see MR flow. So input split, this is exactly equal to block size, and then this is equal to task is equal to getting submitted in number of CPU, right? This is submitted in number of CPU. So if I have 4 block, I'll have 4 input split. Similarly, I'll have 4 tasks, and to submit the 4 tasks, I need 4 CPU. Very simple concept. Now, once you know this, okay, 4 CPU is required, and they all started working. So what is my current progress state? T1, T2, T3, T4. So T1 is completed 100%. T1 is all done 100%. T2 is somewhere on 70%. T3, T4 is also 100% completed. T3, T4 is also 100% completed. Okay. Now question is, how can I track this job in turn? What is the progress state of this job? This job is completed for 370 divided by 4, right? 100, 70. If I take the total percentage, 370 divided by 4, I'll use my calculator to do this. 370 divided by 4. This will be somewhere roughly 9 2.25. This will be roughly 92.25%. My job is completed. 100% once this is done, then they will send one acknowledgement to resource manager that yes, we have completed. But after 70%, this T2 gets filled. After 70%, this T2 gets filled. And this T2 is running in which machine? So let me give a quick name. This is T1, this is T2, this is T3, this is T4. T2 is running in DN1, DN2 and NM2, and after 70% this is failed due to some error, some network error, or maybe CPU is not available, space is not there. Many error can come in your actual cluster, in your production cluster. How this will be handled? Now this is one problem in MapReduce, guys. What is the problem? The moment this fail, immediately this node manager will to acknowledge to resource manager that I was processing this B, but after some percentage this has stopped due to XYZ reason. This will send one log file to resource manager. Now resource manager will read the log file and try to understand why this has failed. Okay, then resource manager will say, okay, no problem, because this B is replicated 3 times. This is why we are replicating the data here. If I lose any block while processing, I repeat, this is a very important point here from the computing perspective, because if this thing is not clear, we'll not understand a Spark also, how they are taking care of it. So if this B block is completed 70%, okay, which I can track, all this 4 thing can be tracked using one port number. If you can tell me that port number, all this T1, T2, T3, T4 can be tracked using a port number of 19888. This is a port number of node manager. Okay. Now B is submitted to resource manager. Resource manager will submit the same B. It can submit here in this machine or this machine. If this has the number of CPU available, then preference will go to this. If it does not have any CPU available, then it will go to this. If it doesn't have anywhere, then it will wait in a queue time to resubmit it. This is what happened, the queue time concept we have seen yesterday. So let's say I submitted my block. Since this T4 is completed, right? This T4 is all done. This T3 is also done. So I can submit in either machine, that in T3 or in T4, because D and C is done. There are one CPU pending now, one CPU free now, which can process one task. So let me take a T3. Let me take this machine, and here I will submit this B block again. Now question is, it will continue from 70% when I submit this to this machine DN3, it will continue from 70% or it will start from 0%. So the problem is, the limitation here in MapReduce is, since this is a disk operation, this is a disk computation, it's not in-memory processing. We're not processing using RAM, right? So this is a disk computation. Whatever output we are getting, intermediate output especially, we're writing back to HDFS. Sorry, we're writing back to local, which is an intermediate location. So whenever you say that this is a disk computation and this is a in-memory processing, disk computation is any time slower than your in-memory processing, guys. I repeat again, your disk computation is any time slower than your memory processing. And this is the major difference or a line between MR and Spark. Spark process in memory, it process disk computation. But I'll not say it has been replaced by Spark. I will do the benchmarking. First, we'll understand MapReduce end to end. Then I'll compare MapReduce versus Spark. So you'll see at which situation we should use MapReduce, though this is complex today, and in which situation we should use Spark. Spark is lightning fast processing, and why it is referred more today, because Spark can handle real time as well as historical data, where MapReduce is not flexible with the real time data. This is the main drawback I could say uh, for MapReduce. So T2 submitted, and T2 will start from 0%. This 70% is gone. It'll start from 0%, and then again your tracking starts. Then once this is done 100%, they'll acknowledge back to let me call this as T2 dash. They'll acknowledge back to resource manager, and resource manager will aggregate the final output. This is the case when your block is failing. Now let's say second case. So this is the case when your block is failing. Let me write it somewhere. Block is failed while processing. Now, within the same case, number two, there's one more point to discuss. This is point, let me call one. And point number two, what if this entire machine goes down? What will happen when this entire machine is down? Let's say this machine is down. If this machine is down, so there is no communication now. Resource manager to name node also, because data node is also not sending any heartbeat to name node, and node manager is also not giving, excuse me, node manager is also not giving any information to resource manager. Now resource manager will internally understand that this node manager is no more working, and then it will check, okay, but this T3, or if any task I'm processing here, right? If any task I'm processing here, all the tasks will fail because this machine itself is failed. In that case, what will happen? Again, resource manager will find out how many tasks is processing in this machine, and it will try to find out the replica of it first. So A is replicated here, and this machine. Similarly, B, C, D. They are checking this all the information in which file. This is stored all in metadata. Okay, so this is all stored in metadata. They are checking the metadata, and based on that, they're taking the decision. So two things: if your task fail, they'll start from 0% in some other machine. If this machine itself is failed, then we need to decommission it, right? Whenever any slave is down, what do? We do decommissioning. So decommissioning means removing, and after some time, when this is decommissioned, then I will newly commission one more machine to satisfy my replication factor and cluster size. Because earlier my cluster was having 4 slave. If I decommission it, I will have just 3 slave machine. To satisfy this cluster size, I will commission it. I'll do commissioning with one data node. Okay, so this is a frequent activity. If you especially work with a commodity hardware, Hadoop supports two hardware. Initially, when Hadoop was found, people said that how can you say this is a cost optimized solution? Because you are having multiple machine. So how can I say this is a cost optimized, right? I need a more number of RAM. I need a good CPU. I need a good configuration. If I do not have, then my Hadoop is taking much time to process anything. Now I can say this is cost optimized using two different answers. That they're using a commodity hardware. They're using a hardware which is a commodity hardware. What do we mean by commodity? Commodity in simple English, this is a cheaper hardware, and enterprise hardware is a costly hardware. Okay, so both the situation is clear that if node is failing or if task is failing, what will happen? Now there is a third case also. There are actually many cases. So if entire machine, or in Hadoop world we call them a node. If entire node is failed or has failed, is failed, it will it will send it will send one communication or log file to resource manager, or I have given some property file in their XML file. So reading that property file, they know that if 10 minute is not coming, then internally this will consider it as no more available in the cluster, right? And if the resource manager is knowing that this is no more available in the cluster, it will start performing this commissioning and decommissioning steps. Case number third is this. Okay, and I feel this is the internal mechanism of MapReduce, and this is the terrific mechanism. This is not available anywhere in programming language or processing framework. Okay, so this is one of the best concept, I would say, in MapReduce. What happened when you submit this job, right? So let me write the job name again: job underscore 5742. This number I have taken randomly: 09172 09172 underscore 897 897. This is a job, and my job is started processing. So T1, same thing. My map will start. My reduce will also start from 0%. T1, T2, T3, T4. Let's say this T1 is all done 100%. Okay. T2 is also done 100%. T3 is somewhere in 33%. T4 is also done 100%. So 3 out of 4 tasks, 3 is done. But if this is not done, I cannot get the final output, because all the tasks are dependent on each other. for the aggregation part. Okay, all the task is dependent on each other for the aggregation part. So how this thing will work? Let's close this. Let's say this actually happens, and I have faced this problem many times in production cluster, especially when I was dealing with a large amount of data. Okay, so let's say I had submitted this job on 21st April, day before yesterday. I had submitted this job on 21st April, and using my monitoring tool. So I have used mostly TWS, Tivoli Workstation. It's an IBM product. There is many option: Uzi, cron jobs, Polar, Autosys. Okay, what they do, they provide you job monitoring. They provide you job monitoring, so you can monitor your jobs. You can do micromanagement. Okay, that how many are killed, how many are succeeded, how many are pending, how many are hold, how many are successfully completed. Actually, in many companies, there is a change task team. There are support team who takes care of it. Okay, so when it goes on production, support team is continuously watching this PWS. They're monitoring it. If they feel any error, if they found any error in the cluster, then immediately they will start troubleshooting it using the PDG file, problem diagnostic graph. If they're able to not understand the actual problem, they'll escalate to their level 2 team. Level 2 team will again investigate all the log file. If they're able to understand, they'll solve it. If they're not able to understand, again, based on the process, this will go to developer. So this is one thing is happening. Incident management and change request every day. So this 33% is not running since last 2 days. Today date is 23rd April. So 33% is stuck since 21st April. So this 33% was done on the same date. But 22nd April, 23rd April, this has not moved anywhere ahead. This is just stuck. I can call that this is stuck. So if this is stuck, and if you're thinking, okay, why I'm waiting for 2 days and 3 days, why don't I kill this? Because you can kill this all the task if you're facing any problem using your port number 19888. This is the port number of node manager. If you kill this, and if you know the consequences, your T1, T2, T4, all tasks will be, this entire job will be failed. If you kill this T3, your entire job will fail because this job is dependent on all the 4 tasks. Okay, what is the better solution here or handling point? Now, resource manager has one internal property. Resource manager has one internal mechanism, I would say, or the concept. That concept says I will immediately launch one speculative task. So, what is a speculative task? Let's understand first. A speculative execution. This concept or the mechanism which I'm talking about is known as a speculative execution. What is a speculative execution? It will it will wait for some time, whatever time you have given in this property file of resource manager. Let's say you have given that any task if it is stucking and that is not progressing ahead from their previous number for last 10 hours. I repeat, guys, if this is stuck since last 10 hour and this is not processing ahead from 33%, okay, it one specific percentage this has got stuck. It's not moving anymore ahead since last 10 hour, then immediately this speculative execution will launch one speculative task. This I can change it, okay? 10 hours I'm giving you one number. I can change this to 20 hour, 5 hour, 1 hour, 10 minute, 20 minute based on my requirement. I think that how critical my job is, how critical my project is, and based on the criticality, based on the severity, I will fix the time. Okay, so all the time which I'm mentioning here, this is all configurable. This is all scalable. It's not fixed that Unlike RDBMS or some Microsoft software that you install it and then you cannot increase this or decrease this. Here, everything is configurable. But to know this, to increase or decrease the configuration property, you'll have to contact your Hadoop administrator. You'll have to create one incident, and in incident you'll have to write all the technical tasks that this is what I want to do. This is a part of your process. So if this is T3 spending since 33% last tenor, then it is launching one speculative task, which is ST3. It is launching one speculative task, which is ST3. And ST3 will start from here 34% or what? It will start from 0%. Now, if you start from 0%, whichever task gets completed first, okay, whichever task gets completed first, so we'll take this way. If T3 is completed first, if T3 is reaches to 100% first, okay, then this ST3 will be killed. This ST3 will be killed. If ST3 reaches 100% first, then this T3 will be killed. I'm not doing this. My job is to run this command. My job is to run this command from client machine to submit a jar file. That's it. That's what I'm doing. And everything internal communication is done by my cluster setup. How the cluster is set and how they're communicating, what number of CPU I have available in my system. So many things I can watch it using my Cloudera manager or Ambari. If I'm using Cloudera, if I'm using AWS or GCP, there are many options, EMR and Dataproc. So monitoring tool is there, port number is there. You can use those port number to watch your services, whether they're running or not running. Now, second thing, so I have got my speculative task. This will start from 0%. Whichever gets completed first, the next one is automatically killed. In this way, without killing this T3, in this way, without killing this T3, I can handle this. Now, if you're thinking, okay, so what if this is also stuck? What if this is also stuck? Now here I can define my number of speculative tasks. I can say if task is stucking two times, one time, then again one more time. So launch one more. This number of tasks I can define in the speculative execution. That ST3, ST3 dash, ST3 double dash. That how many times this is processing. And guys, why your job gets stuck? There's two reasons mainly. Uh, Out of 100%, if you check 99% time, there is just two reasons that your job is getting stuck. Because of CPU is not available to process this data. So if CPU is not available, I can't do anything. My processing unit is not available. I cannot do anything. I'll have to wait. I'll have to increase the CPU time. I will have to increase the number of block size, because we know that if I'm increasing the block size, right, my number of tasks will be less, because number of block is equal to number of input split, and number of input split is equal to number of tasks. These are the major three cases which occurs. Now, so far so good, or the slave thing. But what if this machine goes down? What if your resource manager itself is down? So if your resource manager itself is down, you know that this is a master. This is a master. If resource manager is down, your entire job will fail. Whatever you are running in the cluster, suppose you are running 5 jobs, all the 5 jobs will be cancelled out. All the job will be closed. And this is the reason we work with a high availability concept. We work with a high availability environment to maintain our downtime. That there should not be any downtime in my production cluster, because downtime means I'm losing business. If I'm losing business, I'm losing sales. If I'm losing sales, which means I'm losing revenue. So it's directly causing to my business growth. Okay, so downtime is never accepted in production cluster. Downtime is a U1 always. It's a very high severity production impaired issue. you will have to handle that issue within a minute. If it is not handled within a minute, the thing can be escalated anywhere and your job can be on a stake. Okay, so this is a very critical business. We cannot take this lightly, especially when you're processing such jobs which are running in the production system. So production impaired, we cannot accept it here. This is how your resource manager is handling the job. And to handle this particular case, if resource manager is also down, how can we handle this? This we'll see in high availability. I promise you I'll visit this part separately in yarn, okay? But this is not a right time to discuss the high availability. For now, you understand, if this resource manager is down, your entire job will fail, and we will have to handle this using high availability. That's one takeaway from here. What is the high availability? I will take this part when I discuss our module called yarn. So in yarn separately, I will tell you this. What is HA and how things can work in HA. Next thing, what is the MR flow? What is the MapReduce flow? So MapReduce flow, here we have total 10 steps in MapReduce flow, starting from input, so let me write it first, then we'll explain. Input, input split, record reader, after record reader, mapper, then combiner, after combiner, shuffle and sort. Before shuffling sorting, there is one more process called partitioner. Partitioner, then shuffle and sort, then record writer, then reducer, then final one is my output, right? So this input and output, this input and output is present in HDFS. This is present first. This will be stored when I complete my process. So once this entire process is done, this will again store in HDFS with the processed output, with the logic which I have written to process this. Let's say what logic I'm writing. So suppose I'm having last 100 years banking data, right? Last 100 years banking data. Now I am processing that. How many people have spent more than 20,000 in credit? How many people have spent more than 20,000 in credit? This is my task to handle, right? Out of all 100 years data, you're saying that I want to analyze the people who have spent more than 20,000 in credit. Let's take a bank name as Barclays, because this was my company. So if I write it, um, I can relate things better. 20,000 is the credit more than this, and if I'm shortlisting this information, that's why one of the tasks. This is what I'm calling as a processing or transforming. Okay, so when I filter out the result out of 100 year, let's say this number of record is in total, this 100-year record is in total 1 billion number of rows, and shortly their total their total 5.7 terabyte of data. In short, this is 5.7 terabyte of data, 1 billion record. Now this result is just This result 20K credit. Out of this data, when I'm processing, this is my input file, okay? This 1 billion data is my input file. If I'm processing this information, and then this is my task. So maybe I'm taking just 800 GB of data out of this, because my 800 GB of data belongs to this condition where my credit amount is more than 20,000. This was my task given by a client. So I filtered this 800 GB data and stored this information back to HDFS cluster. This is what happened. This is what happened actually in your system, right? So uh, you know how what is the processing now, right? You're writing this whole logic for what? For simple task where you're processing data more than 20,000. Similar way, I can give you any task. I can say, okay, so tell me that how many people are earning per month £1,000. I can say, okay, so tell me how many people are traveling every month using our credit card. This is all your task area, guys. Okay. Now, if I count this number, so this is starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is total 10 steps for any MapReduce flow. Whenever MapReduce starts, this is the flow. And why we are saying MR is a complex? Because every phase output, every phase output is input for next phase. Okay, let me take this way. Every phases, so input is done. Input output is in this output is input for this. This output is input for this. This output is input for this. They are interconnected. Now, what is the problem of interconnection? If any step is failed, right? If in this from first to 10, if any step is failed, your entire job is failed. If any step is failed, your entire job is failed. This is the problem here, right? Or the task is failed. Then again, you need to resubmit it. So why MR is known as a complex business? Why MR is known as a complex business? Due to this communication flow. And since this is a communication flow of MR, so complexity will increase in this way also. Um, I need to write so many lines of code. If I quickly compare between Spark and MapReduce, right? I think I've done it earlier, but let me again check this. So both started from UC Berkeley University in US. This is from MPLAB, right after 2006, I believe. They started working with it. In 2012, we got the stable release of Spark 1.6.0, which was a very first generation of Spark. So MR benchmarking was to process 60 second 60-second time they used to take, 60-second time they used to take, process 1 terabyte of data using 910 node. Here it is same time 60-second processing 4.27 terabyte of data using just 209 nodes. This is a number of node. This is a number of nodes. Now question is here, okay. So this looks terrific that a Spark is way faster than MR. So if this is 1x time, this is 100x time. What is the reason? Main reason behind this? Because this is a computation, and it's a disk computation. Because if you benchmark this, the next question can be there. Why? Guys, I'm telling you every time that this part should be very, very clear. Whenever you do anything, why you're doing this and why this is happening. So disk computation, and this is in memory processing. why in-memory processing is fast than disk computation. I'm not comparing Spark and MR. I'm comparing actually this disk computation in memory processing, because disk computation means they're processing in CPU, their processing is in CPU, but their intermediate output of this mapper, right, is going to your local disk, is going and storing in your local disk. LFS, I can call this as a LFS. Okay, so in MapReduce we have two phases, mapper and reducer. So once this mapper is done, this output will store in local disk, in local file system of your server, not in HDFS. Okay, if I'm writing in HDFS also, that's also a disk. But in memory processing, what is happening? They're also processing in CPU exactly as MapReduce, but they are not writing the intermediate output in local disk. They're writing their intermediate output on RAM. So anytime, if you ask me, writing anything in RAM or writing thing in local disk, which is fast, which is better, I'll pick anytime this. If the question is specific to fast, but I should be having enough RAM available to handle the large amount of data. It doesn't mean that you're saying, okay, so this looks amazing, and I will give you one requirement where I'm saying that you need to process. We have a data size of 100 GB. Okay, this data can be anything. So we have a data size of 100 GB stored in HDFS, stored in HDFS using replication factor and Hadoop concept. So once this is stored in HDFS, okay, and you're saying that I have a RAM configuration only 2 GB, then what is the use of this thing? Maybe this will fail because you do not have enough caching data available. This is what RAM does. RAM will cache it. This is why your system is faster. Just like your system, if you open your laptop today, you go to new tab, and in that tab you write any website name, right? When you close it down, when again you start it, so what happened? That information is stored in a cookies, in a history. So it does not take more time to upload, to load your website, to load your server. It can take you data immediately. That's a local cookies concept which works in your laptop. If you go to history, what you see? In history, you see that is cookies only. In similar way, when we are processing anything, it goes to RAM and cache it. And this RAM is not a permanent storage. This is a temporary storage. This is a temporary storage, unlike hard disk. Hard disk is a permanent. So permanent and temporary we can refer as volatile and non-volatile. So this RAM is a volatile. Whenever I say volatile, it's not a permanent, it's a temporary storage. Remember, hard disk is a HDD is a permanent storage. This is a non-volatile. So these are two terms which we use, non-volatile. This is a permanent storage. Fine guys. So we have a data size, this requirement if you're having, and thinking that can I handle this whole job using a Spark? I'll not recommend you because your RAM size is just 2 GB. After some time, you start getting cache issues if you're working with the in-memory operation. But Spark provides so many things. In-memory processing is by default. I can change it to disk processing also. I can mix it 50%, 50% also, 50% disk, 50% memory, and I can do many operations. We'll see separately that in Spark. But just a quick benchmarking. This is the difference, and you should know the application. I can never say that MR is my favorite or Spark is my favorite. I should not be doing that because it won't be a justice for this processing tool. You should always take your decision based on the application problem. So you should read first what application is talking about, and based on this application, think that this is fitting best with MR or this is fitting best with Spark. This is why the developer is important. Otherwise, if there is a formula written that use that formula and then decide it, then why they need a developer? Manager himself can do all this job, but this is taking lot of effort, lot of knowledge, lot of tuning part, and then you are able to comment on something. So we should know the application. Nothing is good and bad here. It is purely based on the application which you're working on. Remaining part will continue to know.